Hello and welcome to this register webinar about moving beyond SQL. I'm reading off the slide here, you can tell, delivering personalized responsive experiences. And what I'd normally do at this point is make a somewhat hilarious joke, probably relating to the words moving beyond, but then I got to SQL and I realized I couldn't think of a single funny thing to say. So I'm not going to do that. I'm going to move instead to who we're speaking to on this particular panel. First we have Perry Krug from Couchbase, whose organization helps people move beyond SQL. Perry, what are you hoping to get out of this webinar today?
True. Thanks, John, and thank you for having me here. Thank you to all of the listeners out there. Yeah, I'm an architect with Couchbase, based here in London. Been with Couchbase for about 8 years, and working with a number of our customers, understand what they can achieve with and what the differences are with this new class of databases that we'll be talking about today. I think the main thrust, the main goal of this is just to help understand that there are benefits and value. It does not need to be a new hammer that fits every single nail, and that there are easy ways of getting started.
It's more than one tool in the tool chest.
That's a great way of putting it.
And also joining us is Dale Weil from Dynamics, who's going to bring some real world to the conversation. But Dale, you've also worked in databases as well. So what are you hoping to get out of this?
Yeah. Hi, John. Hi, Perry. At the beginning of my career, I was actually a relational database architect. I'm old enough to have worked on Ingress systems and some of the sort of early Oracle systems, and then later on Sybase. And as databases grew up, I kind of grew up with them. And I still talk to lots of people who are almost stuck in. No, stuck in is probably too strong a word, but still their default way of, when you mention databases, they think about the relational model. And I think the big thing for me, and hopefully over the next hour or so, we can kind of shake that a little bit and really just open people's eyes a little bit more to the fact that it's not that relational is going away, as Perry said. It's more that there are other ways of doing things that are much more suitable than that old relational model now to certain types of modern situations. So just getting to open people's eyes that there is an alternative, that's the main thing for me.
Thank you. And it is this kind of situation we face where I think I'm going to pick up on the word you used there, Dale, which is about moving from a default situation to another default situation. And that's largely going to be driven by what people need, I guess, out there. So here's our agenda for the day. It's how those application needs are evolving, and therefore what challenges are caused by staying with whatever the default was in the traditional past. And then there's some other databases out there, so we're gonna look at some of those, and this is very good that we've got 2 architects on the call, and I wouldn't say 3. I'm certainly not one. So we're going to be looking at how to address this architecturally, and I'm going to turn to you first, Perry, if I may, and let's get a bit more into this evolution of application needs. What are you seeing out there in terms of how your customers are trying to do new things in new ways?
Yeah, thanks, John. And I think we can all appreciate the for lack of a better word, the new world that we're in. We are all engaged with and either involved in building or consuming these sort of digital services or digital experiences, or with internally to our organizations. And the big shift that we at Couchbase and generally the rest of the world has seen is a change in expectation. So the consumers of these services, whether they be employees or whether they be end users, whether they be other businesses that are building their business off of, the expectations have changed and really been driven by the likes of Facebook and Google and Amazon setting out an experience that everybody is aspiring to. And here on the slide we look at kind of 5 of the characteristics that didn't really exist before. If we go back 30 years or so when relational databases came into existence. They were built for systems of the time. They were built for systems with relatively small user bases, relatively small amounts of data, systems that were expected to be offline, systems that were expected to change at very slow rates. And what we find ourselves now, fast forward 30 years, is a completely different set of expectations, where the users of these systems are expecting them to be personalized, they're expecting them to be fast, they're expecting them to be available offline, they're expecting them to evolve as their requirements and expectations evolve.
To be fair, there were some quite big databases back then as well.
Quite big, but not changing as quickly, right?
Okay.
And you talk about Delta Airlines being one of the largest, early adopters of a database system. They had maybe 2,000 people using their database, right? And those were flight attendants and agents at the gate. Nowadays, 2,000 people on your system, you're already on your way out of business. So the scale and the variety has changed. I'm not disparaging at all on previous systems, but it's a question of what were relational databases built for at the time that they were built and still do those jobs very well, and what are the needs of today's applications. And
I'm really pleased that you talk about 30 years ago, because I've only been doing this job for 29 years, so I still feel young in this. I want to turn to you, Dale, but I guess it's a question for both of you, which is how does that translate into what people are saying? So Perry, I'm looking at you as I say it, but I think I'll go to Dale first, which is when you actually speak to people about whatever it is isn't working at the moment, what are they saying? I mean, they're not saying, what I need is a feature-rich, personalized, quick, anywhere, anytime thing. They're saying, what?
Yeah, well, there's a couple of aspects, really. I actually, just as a very quick aside, I remember when I mentioned I worked at Sybase many years ago as a Sybase architect, and we had, I remember back in those days, what we called the 1 gigabyte club, and this was a number of customers worldwide who had 1 gigabyte of data in their Sybase system, and I think we were pushing to get to 10. I'm thinking now that I've got a 512 gigabyte SD card in my camera, and the world has changed quite a bit. But that's the heritage, I guess, of RWMS. Fundamentally, I think there's two things looking at this. One of them is scale and speed. And we'll talk a little bit more about that as we go on, because there are some specific considerations around that, which some new architectures are much better at dealing with. But the other one is change, and there's a couple of aspects of that. One of them is, of course, applications are naturally going to be constantly evolving, but looked at from a user perspective, one of the things that I hear time and time again is we need to keep our engagement systems fresh, delivering new experiences. So we need to keep people bored, engaged. When they're looking for something new and interesting to do, we don't want them to go and switch and go somewhere else. We want to be constantly giving them new and interesting things to do through our systems and touch points with them. And that translates to a whole bunch of stuff, again, which we'll talk about in a minute, in terms of the need for continually refreshing environments and being able to handle continuous change. And the other big thing as well, I mean, we mentioned the word, that word digital. There are, in a customer engagement environment, there's a lot of situations where lots of people call it fail fast, where you're basically experimenting, you're trying something, it maybe doesn't work. You want to be able to very quickly change tack and do something different, and that's just another aspect of change. And so I would emphasize that as well as the scalability and performance side of things.
Yeah, I couldn't agree more. And I think if you step back a bit from the database discussion itself, the application development world has largely made that understanding, right? We're now in an agile world. We're now in a Scrum world. We're not in a waterfall world anymore. And the database, whether it be NoSQL or relational or whatever, has lagged a little bit behind that. right? And so I think it's not just about the technology; it's about the understanding and the expectations and the needs that are kind of catching up to where application development already is. There's no argument that applications are able to evolve quickly, able to change quickly, able to fail fast, and that's now filtering down to the database because it needs to be a part of that's keeping up. So I certainly agree that change is, if not the most, one of the most driving factors.
I think it's interesting. Someone said to me yesterday where that it was all about, for insurance companies, it was all about moneysupermarket.com now. It's not so much that people want the, hey, how can we change more? It's the fact that if Money Supermarket says there's a new feature everyone should have, and you can't tick that box, you're a bit stuck until you can tick that box. So
exactly.
It's being imposed.
And that's kind of what I was talking about initially, was Amazon and Facebook and Google and a couple others set that bar that everybody is trying to aspire to. Your bank now wants to be as easy to use as Amazon, right? Your insurance company, as you said, wants to be as easy to use and have the features and be available and be fast as Money Supermarket. So it's this expectation that's being set higher and higher, and now all industries are needing to are being expected to meet that for whatever their particular space requires.
Dale, I'm gonna turn to you in terms of what that means in practice, because sure, we've got to get to the database, but we've got to go through the application level. And what kind of impact are you seeing that having in terms of the kind of applications people are having to deliver?
Yeah. Have we moved on in terms of slides, John?
Yes, we have.
I can't see slides here.
Yes, we have.
So a couple of things, really. I mean, firstly, we're finding that execs in most organizations now are very, very systems aware. And one of the data points which I think I put into the deck that we're using here is that actually customer engagement systems is now the most front of mind. It's not that they've stopped worrying about their SAP environment and their Oracle systems behind the scenes that sort of run the core business. It's more that they've realized that customer engagement systems are now critical to so many aspects of their success, and you don't need to sort of make that case to them anymore. I think they're all consumers as well as they are business leaders. So in that sense, it should be pretty straightforward to get that message across. There's a slide there on some of the characteristics of applications, and I think this is a really key slide actually. If you come at it in from a different direction, and you say, well, look, how many applications do you have that tick these boxes or have these kind of requirements? And there's a whole list here, but there are a few things that come through time and time again. And 80% of people in a survey we ran recently said, yes, we have at least some of applications that meet at least some of these or have at least some of these requirements. One of them is rapid growth, which we kind of touched on, and obviously, that translates to scalability needs. But also web scale was another thing. More and more, it used to be the exception. Now it's becoming pretty normal. We need web scale in at least some aspects of our customer-facing environments. But then the ones which I think are really key are highly fluctuating applications. This is where you've got applications that have lots of peaks and troughs, or they have bursts of activity. And we all know from experience when you're designing systems, sizing systems and so on, those bursts are often the killer. That's where, when you've got peak demand, you've got most customers on your site trying to engage with you or through your mobile applications. That's the last point at which you want the system to choke. So dealing with those kinds of applications is becoming now pretty normal. And as I say, over 80% of people we spoke with are saying that they have those kinds of requirements emerging. And then we've already mentioned this, frequently refreshed and update applications. So no surprise, as I think we've already mentioned this, that's what's leading people to methods and approaches like Agile and DevOps. And again, we see most mid-size and larger organizations being pretty active in those areas now. Not necessarily doing everything that way, but certainly the customer-facing stuff tends to sort of lean in that direction.
There's an interesting point that I'm picking up as well. I'm looking at that picture. I didn't make this up, by the way, guys. This isn't scripted. That's the things that seem to be less interesting to people are around the shorter lifetime tactical solutions. So it's looking like you can kind of focus, you can kind of get right what it is that you're trying to deliver in terms of overall applications. But the things that people struggle with more are the tactics within that application. So how big or how small it needs to be, what particular features it needs to offer, etc., as opposed to the application itself being thrown away and replaced by something else.
Yeah, and I think that there's a really key thing here that we hear time and time again, and that's that tactical applications, disposable applications, situational applications, as some people call them, are really a bit of an illusion, because once that stuff goes in, it very rarely gets decommissioned. They just tend to live on. And that's why building them on a solid foundation, having the right architecture in place so you don't have to work hard to make them robust and make them change-friendly, that's really important, because you never know where those applications are going to go. And they're probably likely to, some of them will stay there and do nothing, but there's an equal chance that they might actually go off in directions that you never anticipated.
Yeah, I really like this view of things, the list and the topics that you have here. Oftentimes I get into conversations, well, all the time I get into conversations about, is Couchbase or any NoSQL going to replace all of my Oracle? Where does this fit in my system? Right, I have hundreds, maybe even thousands of applications. Are they all suitable, or how can you tell me which ones are? And so I think this really helps lay out, and is something that I talk about quite frequently, is the requirements of the application are what drive the tool that you should use to support it. And all of those requirements you have on the left there are characteristic of the kinds of use cases and applications that Couchbase and other NoSQL technologies are kind of the best fit for. And if you have an application that doesn't fit into one of these categories, it's probably not a good fit for it. And so this helps create a filter that if you have some many or all of these requirements, there's a very, very high likelihood that you will be well served by a new type of database, or conversely, that you won't be served very well by kind of a traditional legacy relational database.
Yeah, absolutely. And I always think of it as a point system. These things are not mutually exclusive, but if your application, if you put a tick against maybe 2 or 3 of these requirements, then you really should be thinking a little differently in terms of the stack, the architecture that you put it on. So think of it in that way. There's no absolutes here. You can twist and bend any system to do things it's not naturally fitted to do. We all know that, and we've probably all done it over our careers. But I guess what we're saying is, just recognize that if you stack up enough points in a particular direction, then you should be changing your thinking and looking at a different solution.
Sure. And you see this list of 2, 4, 6, 8, 11 or so kind of falling nicely into those categories of change or, as you said, speed and scale. And so, very kind of balanced. If you have the need for one or both of those, it's a sign that you have this kind of application.
Okay, can I just mention one other thing at this stage, because I think it's something which, it's easy to talk about peaks and troughs and so on. Time and time again, we talk to people who've built an application or a service, in the world of microservices and API-driven architectures. You might build something to meet a particular need, and then you find that something is used in ways you never anticipated. And a good example of that is anything to do with customer lookup or simple customer transaction stuff. New applications come along that weren't really a part of the agenda when you built that service. That service needs to be able to cope with that, and I think that level of unpredictability is not just about what are customers going to respond to or not respond to in that fail fast and change tack quickly thing. It's also about some of your colleagues down the corridor might do something with what you've just built that that is totally unexpected, and so you need it on the kind of architecture that we've been talking about.
Yeah, it's almost predictable unpredictability, right? You want to plan. You want to plan for that because if you don't plan for it, it's going to happen anyway.
Yep.
I'm kind of seeing that in two of those lines on there, which is that people are recognizing they need web scale performance. They're not necessarily seeing the drive to scale up quickly as much as knowing that they're going to need it. So it's the predictable unpredictability, if you like. And if we take that into moving on to the next slide, if we take that into that's the kind of generalities of applications, more the specifics of applications and where they map onto their kind of data management needs. So maybe you can lead us through some of that, Perry.
Sure, yeah. And again, that set of requirements, I think you could say every one of these systems, every one of these use cases, every one of these applications comes back to that core list of requirements that we looked at. And so if you take some examples, and it's hard to talk about a very specific use case. Is it a caching layer? Is it a source of truth? Is it a user profile? Is it a customer 360? There's lots of different ways of looking at it. But if you start to think about the kinds of services, the kinds of applications that you're trying to use your data to create, you come on to a page sort of like this, and you can look at very high throughput systems in terms of session databases and IoT applications. You can come into catalog and product inventory systems that may have once sat kind of in the back of your organization, of your application, but now you want to expose that data a la the way Amazon does. You want to make it more available to your users. You want to make it more personalized to your users. You want them to be able to have access to it.
Can I ask can I just briefly interrupt you here, because all of these things seem to be talking about kind of quite specific use cases. And
yeah.
So what I'm hearing sometimes when I do this sort of thing is, don't worry about any of specifics. All you need is a big data lake. You just chuck it all in one place and have the biggest possible data source, and then you can drink from the waters of a massive pool of data, and in any which way you want. Whereas what you seem to be saying here is you will have you need to work out what it is specifically that you're doing with your data in advance of doing it. Do those two things agree with each other, or is there an incongruity?
I don't think that you have to work out what you're trying to do with it before you do anything with it, but you do have to have a goal in mind. You have to have a type of service that you're looking to provide. I mean, if we think about kind of the related discussion as you brought up with the data lake, the Hadoop technology and vendors of the world made a big promise that just put all your data into Hadoop and you'll be able to mine it and get all this value out of it. And I don't think the world is really seeing that. I don't think they're getting the kind of value out of it because they don't know what they were trying to do in the first place.
We're hearing about silos of Hadoop, aren't we? And
Yep. So I mean, this is talking more about looking at it from the perspective of your consumers, your users, your employees, your customers. What are you trying to enable them to do, and then build the system that does it, or build the system that allows you to do that. And it's going to manifest itself in a couple different ways. But just kind of blindly throwing everything you have into a single system, and you're not going to be able to produce the kind of value, or go back to that list, meet those requirements. You're not going to be able to provide the flexibility and the speed and the scale and the mobile and the unpredictability on top of something that wasn't designed to do that.
So
yeah, there's another way of looking at this as well, which is if you were to characterize Hadoop at a high level, it's a kind of batch-based environment fundamentally, and that's great if you want to do lots of number crunching and analysis and feed that into the decision-making cycle and so on. What everything on this slide has in common, though, is it's pretty much all real-time, and I'm using real-time in a loose sense, not in a sort of, my colleague Tony Locke would pull me up. Real-time means something specific in terms of physics, but generally speaking, this is all about very fast, instantaneous response to what's going on the front end, in the front end of the environment. And I think that's what we're talking about here. So when I think of engagement, I'm thinking about that sort of as it's happening in the moment type of engagement, not who should we target from a segmentation analysis point of view, which is where Hadoop and other things sort of kick in. Does that make sense?
Mm-hmm. Yeah, absolutely, and I agree. And you know, the conversation has shifted a little bit from where it was 5 years ago or longer, but back then it was a question of everything is big data, and if you're big data, then you are Hadoop. And so we struggled for a little while in trying to carve out a place that said, yeah, there's this big data umbrella, which is all about flexibility and gaining new insights and providing new services on top of, you know, this unstructured data. But it's not all about data lakes and batch processing and number crunching. There is the real time, the front end, the user engagement side of things, and so those two kind of come together very well. And there's no situation where I would say Couchbase or any kind of traditional NoSQL technology would be a replacement for or even a competitor to Hadoop. We operate in very much the same environment, serving two very different needs. And if you look at the technical architectures of those kind of two products, you see that they're designed for very different things. They are set up for and do things and store things and distribute things and provide access in very, very different ways that are much more complementary than they are competitive.
Yeah, absolutely.
So what you're saying is it helps to be specific for sure at this point. And I just want to bring in, so Jason has just raised a point, which is not only does it help to be specific in terms of what you're trying to do, but these days it was ever thus. If you read GDPR, it's just taking best practices to date, but putting a bigger fine on it. But as Jason points out, unless you specify why you are collecting data and how you're going to use it, you're likely to be in breach of GDPR, never mind the fact that you're not necessarily going to be able to do everything you wanted.
What you want out of it. Yeah. No, it's a great point. Yeah, I mean, we're all living in this world now, and there's certainly various layers of data collection and data usage and data transfer and what you're doing, and then security is a huge part of this discussion and should be first and foremost in everybody's mind.
Mm-hmm. And there's another aspect to this, I think, which is I hear a lot of people saying a fundamental part of what they're doing with customer engagement systems is enabling self-service wherever possible and giving customers visibility. And obviously that's something that needs to be properly designed and understood in terms of what's appropriate in any given context. But I think unless you have the right kind of architecture in place, it's very hard to give individual customers individual visibility of certain key bits of information or activity that you're holding on them. And that's independent of GDPR. In many ways, that's a customer experience question, but it is related to GDPR in that customers are less. If customers see you being transparent and they can self-manage and they feel they've got an element of control, they're much less likely they're much more likely to see the value of that translated into the facilities you deliver to them through the engagement systems, and much less likely to challenge it from a GDPR or privacy perspective. And there's an element of psychology in that, but it translates directly to systems design.
Yeah, absolutely. And let's bring it all back to what we were talking about before. The ability to react to new regulations, the ability to react to new requirements is change, is part of what we're here to enable. And if you are, GDPR is not the last law, the last regulation, the last change that we're ever going to see. It's an example in a long line and a continuing line. If you're not prepared for the next one, but you don't know what it's going to be, if you're not prepared for that, you're not going to be able to take advantage of it.
I mean, that one did take 21 years, so I think we've got we've got a bit of time. But so just to summarize where we are then, so we've got world's changing. It's more and more about understanding the customer driven stuff. So customer engagement systems are becoming more and more important, by which where the business meets the customer and the software that we put around that is becoming more and more important. here's a bunch of ways that you can see that, but what we've just been talking about is it's not just a case of take all their data and try and do something with it. You've got to be actually a bit more specific about that. And so let's move on from there. And so the $1,000,000 question is, why can't we do that with SQL? And I'm going to move on to the next slide, Dale, as we ask that question.
Yep.
Yeah, and I'm gonna correct you for a moment, and just try to make a point that SQL, in its specificity, was never the problem.
Easy for you to say.
The language is elegant, is mathematical, is very good at what it does, and you'll see, in fact, used by Couchbase and other technologies. It's the architecture of relational databases underpinning it, and unfortunately, those two get confused and conflated all too often. But I don't want to give SQL.
Okay, I have shown
name.
my hand as not being a database.
That's fine. That's fine. But it's important for people to really understand that it's not the language that was ever the problem. It was as we're seeing on the slide, the stuff underneath. So yeah, I mean, we've talked about some of these, and Dale, you brought up the change. If we look at the first and the third on the screen, the way that the relational databases manage schema is in a very rigid, hard to change manner. And then if you jump to the third, the inability to scale is not just about performance or scaling, but it's about changing your architecture and adapting to new requirements. And sometimes those new requirements are store more data. Sometimes those new requirements are provide more access to it. Sometimes those requirements are provide different ways of accessing to it that puts pressure on different parts of the system. Mm-hmm. And so that's something that traditional relational databases have not been very able to do, because they never were designed for that, and really shouldn't be used for that. Sure, you can throw hardware at a problem, right? And that's a very common thing to do with relational databases. Get a bigger box, put caching layers on top of it, spend more money, and you'll get more speed. And that's true to some degree, but there's always a balance of is it worth doing that to be in a system that wasn't designed to do what I'm trying to make it do.
And I'll just interrupt you very briefly there to respond to something that's just popped up onto my screen and say we will be going into the details of why this is the case very shortly. So this is we've got the facts here. The screens are rigid, and we'll go into more architectural deep dive very shortly. Yeah. There you go.
Yeah, I mean, can I just add a couple of things? I think, and just for anyone out there who's running a big Oracle rack system, for instance, who would probably take issue with the concept that you can't scale a relational environment, but I would just add the word economically on the end of inability to scale. Yes, there are physical limits, and we'll come on to talk about some of those, but I think these large-scale relational clusters cost a fortune, and they take so much maintenance and management as well. And I think that's one of the biggest impediments to actually scaling some of these environments. And it's at least as much of an issue as some of the physical constraints that are there. On the just to be fair to relational databases, what I would say is one of the things that they are quite useful for is when you're maintaining and enforcing integrity in the database layer itself. So, we all know about relational databases, and the relational model won't let you do anything which is going to put the database out of in an inconsistent state, and that takes the onus off a lot of developers in terms of it's a very forgiving environment in that sense. And I think in a NoSQL sort of dynamic schema environment, it's sometimes it's easy to you're putting more control. I think of it as you're almost kind of riding bareback. So you have to be a little bit more skilled and a little bit more aware of what's going on. So you're not being handheld all the time. But obviously that handholding comes with a price in terms of performance and complexity and so on. So it is a big trade-off.
Yeah, that's very true. And I mean, we're not here to say that relational databases are inherently bad. We're not here to say that you should not use them. We're not here to say that you should replace them with something else. And it's hard to walk this line that says here are some challenges, and some of those challenges are in place for good reason, as you just said. It's really what we're trying to say here, and maybe it's hard to do, or we're not doing a great job. But we're trying to say that there are tools for different jobs, and that if one tool presents a set of challenges, there is maybe another tool that alleviates those challenges and introduces some others, and so you're making this trade-off. Yeah,
it's about context, and we're talking about the customer engagement context, obviously here, which changes the game, doesn't it? As we said. Okay, great.
So. We've got a question that's just come in, which is, other than banking transactions, are you aiming and suggesting to move to NoSQL and Couchbase? I mean, is it a one-size-fits-all beyond anything that just requires you to store records, I guess is the broader question.
Yeah, I mean, it goes back to the you have to understand what your requirements are, and you have to understand what tool fits those requirements. One of the big requirements, though, is that you don't know what's going to come, right? And so that's an interesting conundrum. Is how do I choose something that prepares me for the unexpected? And we at Couchbase we think that the technology, the architecture, the design that we have built allows us to react to the unexpected, just in the same way you are building your applications that have to react to the unexpected. Yeah, why don't we go to the next slide, and we'll use this to talk about it a little bit.
Oh, that's building.
Yeah, I don't know if you all on the outside line see that building up, but if you look at just the right-hand side, there used to be a world of just transactional and analytical databases, and there was always that little middle bit of overlap, but neither of them was really in a place to serve all of this customer engagement that we've been talking about. And so organizations have found themselves adding layers and layers to do different things. So first you add a caching layer, then you export your data to a search engine, then you export your data to something that can index it differently, then you set up a new system where you import the data that you can do some replication around, because you need to get your data to a different part of the geography, and so over the years, this has built up into a very complicated way of managing data. And you have data that's different in different places. You have technologies that have different APIs, that have different integration points, different programming models, and so really what Couchbase has done is kind of look at all of these different technical capabilities and built a platform that allows you to meet many or all of them. So we call that an engagement database, and
so clues in the name.
Clues in the name. So for systems of engagement, right? Not for data lakes, not for banking transactions, not for data warehouses and batch processing systems, but for your customer engagement. And so we look at these kind of 6 aspects as strong requirements of what you will need to meet, what requirements of the database that you'll need to meet the requirements of your application. Now, if we start to talk about Couchbase, kind of compare and contrast to relational databases, you see a lot of areas here that are common and that are different, right? Your big Oracle rack systems are not running in Amazon. They're not running in a container architecture. On the bottom right-hand corner, they are secure, and both Couchbase and every database should provide a degree of security. So I'm not going to go through all of these individually, but the other compare and contrast is to look at Couchbase versus other NoSQL technologies. And that's where I think you'll start to see some much starker differences, where some new database technologies make it very easy to work with data, very easy to flexibly build a prototype, but they don't scale so well, or they don't provide the kind of performance that you need. On the other hand, there are some technologies, and we're not having a competition discussion here.
So
but
you're specifically looking to address this specific issue around customer-facing scalable apps.
Customer-facing scalable apps, engagement apps that have a variety of requirements, and I think that's the key aspect. Is there are varieties of requirements, be it searching, querying, performance, scale.
So I'm going to jump through some of your customer examples, and then we'll look at the architecture diagram.
Okay.
So very quickly, you've worked with lots of people doing this kind of thing.
Yeah. And there's a lot of names up here, and many of them here in the some of them here in the UK, some of them here in Europe, some of them over in the US. You see a wide range from financial institutions like FICO using Couchbase as a part of their fraud detection user profile stuff. You see United and Amadeus there doing lots of travel and hospitality related applications. I don't know, do we want to talk about any of these in specific? All of these I think you could class as digital organizations. Some of them are very old, some of them are new, but digital organizations that are providing those applications and services to their
Okay,
users,
so let's
consumers.
move on to the kind of the how and the what it looks like, because
Can I just chip in with a point before
and
we...
you can, you certainly can do. Yep.
Yeah, only to say that we're looking at some household names on this chart, and that what we don't want to do is send the message that this is only relevant if you're a very large organisation with very millions and millions of customers. If you focus on the change aspects and the rapid deployment aspects, that's equally applicable to smaller businesses. So don't sit there thinking that this is only for big companies. It really isn't.
Okay, so thank you for that, and that fits very well with the question that we received, which basically is this discussion relevant to my needs? You've talked about large numbers of users, but I work in a small business with 25 users, so that's very fitting that you should ask that, and I want to ask that question of you at the same time as sticking this architecture picture up. And I also want to bring in Ben, who's said, can you explain the differences, advantages of Couchbase versus SQL? So all of that in the next few pictures. So why precisely can any organization of any size who's looking to start delivering scalable customer experiences in the digital world, why Couchbase?
Yeah, well, I think that's exactly the point. If you are looking to provide engaging experiences to your users, to your customers, to your employees, then this discussion is relevant for you. And going way back to one of the first slides, we put up a list of 9 or 11 requirements of the applications, and they weren't all about large numbers of users. They weren't all about high scale. They weren't all even about large volumes of data. There was a big aspect of change and evolution. If you have requirements that need the changing of and evolving of data, and then the presentation of that to your users, then yes, this is that relevant discussion for you. And there are organizations that started off very, very small with a big idea, but it takes you a little while to get there. And even if your goal is not to become the Uber of the world, you may have those needs of evolving data, changing data, providing different access patterns to it, also that you can make for a better customer experience. Yeah, I mean, this slide talks a little bit about where Couchbase fits in a variety of kind of enterprise architecture layers, highlighting that we're not an overlap or a compete with the Hadoop technologies, with the Teradata data warehouse technologies. We work very well with things like Kafka and Spark and Storm, and so really focused on that caching and data serving layer there in the middle, that's where your users are engaging with your data. And that's where you're building applications to surface data for your users to engage with.
So, something I wanted to bring up earlier, actually, that is Couchbase's existence predicated on in-memory notions? Like when you turn the machine off, it goes away?
No.
Kind of notions?
No. It's a fine line to walk. We try not to say in memory, because in memory implies, as you just said, although I have it here on the slide.
It's on the slide.
I know it's on the slide. We talk about Couchbase being a memory-first architecture.
It's on the slide, Perry.
I know. Well, you want an in-memory cache, but
sure,
you want a data serving layer as well.
But you're also down here as well, aren't you? So
right. So we talk about memory first, which is what gets us a lot of the performance and a lot of the scalability. But there is a very strong focus on persistence and availability and replication in order to provide a resilient layer.
So and equally, this slide shows. It doesn't show everything that everyone should need. It shows everything you might need and how Couchbase fits with that. So presumably there's a very small version of this for that 25 user organization. What would that picture look like?
Yeah, I mean, you might have, if we go on the bottom, you might have a social media application there in the middle, or let's say maybe you're building an application that pulls from Facebook or Twitter or WhatsApp. It's pulling some of that data and providing another layer on top of it, providing a service on top of it. So you'd have data coming in from that source. You might ingest that directly into Couchbase and then build an application on top of that, and it becomes a kind of a simple stack. That gives you that benefit of either speed or change, evolution of data.
And just to make sure, Dale, maybe this one for you as well. Make sure I'm understanding what we're talking about here. So, actually, what we're talking about here is when you have those specific needs. If you're trying to address them with a pure SQL environment or with any traditional environment, you're going to start to struggle in certain ways. Couchbase can sit as this kind of layer or independently, or it can be used as the thing in order to address these specific issues. So it's not an either, as you say, it's a tool that you can use within your stack in order to, as you say, surface data.
Yeah. Well,
there's something we haven't touched on yet, and I don't know if it's worth doing this, Perry, which is fundamentally what's the difference in terms of how the data is held in a relational database versus a document sort of centric NoSQL database like Couchbase. Let me have a high level stab, and then maybe you can correct me, Perry. But the way I see it, when I was an architect, we would denormalize databases as much as possible, which basically means we would break everything and spread it out across lots and lots of different tables and indexes, and then a query optimizer would pull it all back together again at runtime. And the idea was we only ever store one piece of information once, and it's all sort of spread around and broken into pieces. Whereas in this kind of environment, where we're not spreading everything out and incurring all of the overhead that goes with that, like lots of heavy indexing just to retrieve the stuff back, let alone do anything sort of adventurous. And we're holding data which can be relatively unstructured or totally unstructured in a way that allows it that sits the same or similar data to be retrieved very, very quickly. You can probably explain that a bit more elegantly than I can, Perry, but does that kind of make sense?
No, you're absolutely right, and that's certainly one aspect to it. We talk a lot about the impedance mismatch between an application and its relational database. And if we think about a very simple kind of user profile database where you want to store Dale, you have a user name, you have an email address, you have a physical address, you have maybe a list of friends or products that you've bought. That is your user profile, and the application is going to kind of ask you for that information, and then it's going to provide it back to you as that object. And in the application, it's an object. It's your kind of user object, and I have mine, and John has his, and those are objects within the application.
Yeah.
But as you detailed, that then gets split out into a variety of tables that then have to be put back together. And it just doesn't make sense when all you want to do is serve or look at that object as a single unit. I heard a story or a way of characterizing this, that you're driving along in your car, and at the end of the day you go home, and putting that car into a relational database would be like taking every part off the car and putting it in a different place in the garage, so that the wheels were all with all the other wheels, the doors were with all the other doors, the windows were with the other doors, and you go to sleep and you wake up the next morning and you go and you build the car so that you can drive it down the road.
I'm reminded of Iron Man for some reason.
Right, put all those pieces together. That's like an application doing that access to a database, and there are times when that makes sense because you want to store all of the same pieces together, but there are times where it's just a mismatch and doesn't make sense. Go to the next slide. This is a good way, I think, of looking at how does Couchbase fit into an architecture? How do you get started with Couchbase, and what are some of the things that some of the benefits that it can provide? As a very simple caching layer, Couchbase can offload a lot of the workload to a relational database or any storage layer that isn't as good at doing it. And so sometimes that's a matter of the speed at which it can create those objects and those joins, and sometimes it's the flexibility of how you want to access data is just more challenging to pull that out of a relational database. And so this is not just about performance, although a caching layer typically provides better performance on top of whatever it's caching, but also the ability to look at and store data in different ways, so that you can present that quickly and interactively to your users.
Yeah, I see that as almost pre-aggregation in a way, and the whole record is there for that profile sitting there, so an application developer can just go bang and it all comes out in one, which is why it's quick, but also why it's a lot easier for the application developer who's not having to traverse the data structures behind the scenes.
Yeah, and actually Olivier just asked a very good question. I'm gonna read it out, but he says, in a software as a service environment, sorry John, say you store data for customers, they can add custom fields, and NoSQL kind of makes storing and extracting or displaying those individual records much simpler. But he says, however, there's also a need to provide searchable, sortable list views. Is NoSQL well adapted to be able to provide these kind of views in the UI? And I like this question very much because it goes exactly to the challenge that Couchbase is addressing, because without a platform, without a database platform that can provide different access patterns, you end up with one technology just to store the data, one technology just to cache it, one technology just to search it, one technology just to query it, one technology just to analyze it, and you end up with, and then another technology to replicate it to another stack where you're doing all the same things over there. And sure, you can do that, and you can choose Redis, and you can choose Mongo, and you can choose Cassandra, and you can choose Neo4j, and cobble all of these things together. But at the end of the day, you're creating a single user engagement system. And I would make the assertion that Couchbase provides a variety of different access patterns exactly because your system needs different access patterns. You need to be able to store data. You need to make it easy to extract and display quickly individual records, but you also need the ability to search on that data. You need the ability to replicate it and all of that, and that's what Couchbase does, right? Mm-hmm. It's not just a NoSQL. It's a platform of a variety of different access patterns all put together so that you don't have to worry about managing the different APIs and the integrations and the upgrades and the operations of each of them.
Including SQL, Perry?
Including SQL, yeah. So I mean,
mention that.
No, it's a good point. We didn't talk about it too much, but we have our own query language. It's not called SQL, but it is very, very similar to it. It's built off of the same base that SQL has, and has support for things like joins, has support for things like group bys and aggregations in a very SQL-like language. We don't have a slide on it, but you literally have the select star from where, group by, order by, sum, count, all of that built into the language the same way you would from SQL. And the reason,
I have no idea what that just meant.
I know,
but
I'm just rattling it off. Somebody
okay.
out there, someone out there understands.
Okay.
But the reason, sorry, the last bit, the reason that we did that was because everybody is familiar with SQL. We want you to be able to be familiar with how to access data in Couchbase. But also, back to my point, John, that I said earlier, there's nothing wrong with SQL as a language. And so we used it because it was built very mathematically, very algorithmically to do what it does and works very well for us as well.
I'm feeling very thick here as well as completely redundant. I was about to say, we've got a question from Olivier. Oh no, but we've done that
Sorry,
because
John,
Perry's already asked it of himself.
I got on a roll.
Oh God, I've nothing to do here. But just to make sure that I understand. So we're actually seeing the need for, the word caching was confusing me a bit, I confess. So caching to me is like you get the data closer to where you want it to be and then you hold it there so it's still there next time. What you're talking about is a kind of pre-fetch and pre-configure mechanism. So you already have the objects, and so you already have the cars. You don't have the windows and so on and so forth. It's already in the shape that you need it to be because of the way the Couchbase base operates.
Correct.
So you're not having to have the delay of building it every time that you just need to say that bit of information from here, that bit of information from there, and that is the problem that we're solving here to speed up that customer engagement.
Correct.
Process.
That's one aspect of it. Yeah. And Couchbase, I think, is unique in its ability to be a very good caching layer, and we can talk about some of the technology behind that, but it gives you a very kind of stepwise approach to keep your data if you already have a relational database, keep your data there, put Couchbase in as a layer that can speed up the access to that, and then slowly over time get more experience with Couchbase, figure out what data was never meant to sit in that relational database in the first place.
Because it's not just a caching tool, is it?
It's not just a caching tool, right? But it's a good place to start. And if we look at a little bit more complex architecture, you can start to think about using Couchbase as an aggregation layer where you have data stored in other technologies that do what they do best, but through things like Kafka and Spark, putting that into Couchbase lets you provide the systems of engagement, those applications on top of it.
And just as again the Lumux question here, do you need Couchbase if you don't have this problem, i.e. if you're not using multiple data sources and you've already got your cars, you haven't got your windows and doors in separate spaces?
Yes, no. I mean, it depends on. We have users of Couchbase that their whole application is just Couchbase. Right. And those are so fine.
Single instance Couchbase, if you like.
There are some that use Couchbase in conjunction with Hadoop. There are some that use Couchbase in conjunction with relational databases. There are some that use Couchbase in conjunction with other technologies. So it's all about what are you trying to achieve and where are you coming from? Do you have an existing structure that you're trying to evolve, or are you starting greenfield?
Dale.
Yeah, and there are situations where you have very natural affinity between different data elements. So it does make sense to actually store them in a single place in the database. So they're 99 times out of 100, if not more, you're going to be accessing those together. So why there is no real benefit to spreading them out across a relational model and then pulling them all back together again when you need to access them. So there are applications that come up quite frequently nowadays, particularly around unstructured data and fast-changing customer data, that fall into that category.
Okay, so I think we've got 3 minutes left. So what I want to do now is just try and summarize what we're saying. And the first thing that we're saying is you don't have to just see everything through the spectacles of an RDBMS. I think. Well, we've got a list here. Look, let's work through this list. So I think most importantly, yeah, it's a big list, got lots of words about requirements and so on and so forth. But Perry and Dale. Maybe you first, Dale. If you were speaking to an organisation about trying to solve this kind of problem, start with the architecture. What's the starting point that you would recommend to them?
I think the starting point is to get your head around what it is we're talking about here. So actually getting up to speed on this. You know, read as much as you need to get the gist. Then get a little bit of hands-on through some piloting, some prototyping, etc. And the penny will drop very quickly on what the difference is between these kind of environments. And once you've done that, you can then start to say, okay, now I understand what this really means. You know, I'm not just dealing with theory, and I can see how that can be used.
And that fits with the question we've just been asked, which you might want to pick up on. Rather than trying to figure out what systems problems can be solved by Couchbase, which is many, are there any examples where you must still use an RDBMS? Is it invoicing systems, financial transactions, or is this the wrong way of thinking about it?
I think the way I would phrase it is there are systems where RDBMS is a much more natural fit. If you take invoices, for instance, I might want to look at invoices by customer, by status, by matching them with a blanket contract. There's lots of different ways I might want to access very, very structured invoice data, and invoice data is generally very structured.
Okay.
That's a very natural fit.
Okay, and over to Perry in our final minute. Perry, what would you advise people, as well as look at our free training, which happens to be on here?
Yeah. On that last point, I agree. It's structured data. It's data that you need referential integrity to. Transactions are a hard kind of topic to talk about, but there are cases where you need to very tightly move data from one place to another. That is one of the trade-offs that you find with NoSQL systems, and so if those are requirements, then relational databases are good fits. I feel bad. Ben asked the question a while ago, and I don't think we really answered his question very well about the differences, advantages of Couchbase at a technical level versus SQL and other NoSQL systems. But what I would say is to direct you, Ben, to that second link on the screen. The training that we provide and other companies provide gives a very good overview of, similar to this discussion, but in more depth, of what are the kind of high-level and the low-level technical differences, the use cases, the systems that would be helpful to follow up on.
And I'd also say to you, Ben, that if you have any further questions about this, by all means, do not come to me, because I will not have answers to them. But if anyone does have any further questions, then by all means do send them through, and we'll make sure that they get to the right people in Couchbase or elsewhere, so that we can answer them for you. And it just remains for me to thank you, Perry, for joining us on this, and thank you very much, Dale, as well. Hope you, the listener out there, have got something out of this. Hope you've got somewhere you can go with this new information, and look forward to speaking to you again next time. Cheers, thank you.